So now, we are going to use this basic unit now to derive the dimension and all the units and also the dimension of some physical or derived physical quantities. So now, we are going to use all this now to derive the dimension of some what the unit and dimension of some physical what quantities. Now, for example, I will give it step by step. Now, for example, now we have, for example, velocity. Is the first quantity that is made up of two physical quantities. Velocity, you call it is what? Distance all over what? Time. Distance all over what? All over what? Time. Now, distance here is the SN of distance. Remember here we say velocity is what? Distance all over what? Time. So the first thing to do here, remember we say that distance is measured in meter, time measured in seconds. Meaning, we are going to replace distance with this unit, m co, here, since length, distance, and time are all the same co. Now, and also all over what? Second. So this will follow negative index rule of indices. This will come up and it become what? Negative sign. Here we have the rule says a to the power of minus n equals what? 1 all over a to the power of n. You see? Meaning this can come up and become this. Then here we have m s minus 1. So let us write a dimension now in this case. Remember that we say that meter is length go because it's equivalent to what? To capital N in dimension, but capital what? N. Then seconds, that is time, is equal to capital what? T. All to power what? Of minus 1. So you see, this is how we represent dimension. Here is the unit. And here's the dimension of what? Of velocity. So now, after velocity, there's another quantity that depends on velocity. That depends on what? On velocity. This one is known as acceleration. Acceleration. Which is velocity all over time. So now, remember that the SI unit of velocity that we derived is this. If you say here we have meter per second, that is the unit of velocity that we have derived is this go all over time, which is also in second S. So this S can still follow the same rule. Remember that we said if we have two bases, division between the two bases, we subtract the powers. Now this becomes equals to m s minus 1 times this one. This comes up, we have s to the power of minus 1 again. It follows the same rule. When it comes up, then here we have m s here minus 1 equals to m s minus 2. And its dimension here will be equals to L as meter go, then time second is capital T minus 2. This is the dimension of what? Of acceleration. So after acceleration, there is another quantity that depends on acceleration. We call it force. The word force. Mass times what times? This is we have mass times what? Acceleration equal. Remember, force is what? Mass times what? Acceleration. So now, we have mass times what? Acceleration. Remember now that the SI unit of mass is kilogram kg here. And SI unit of acceleration here is what? Meter per second square. Now, this is the SI, this is the SI of force. This is force is mass times acceleration, and mass is in kilogram, multiplication go, acceleration, A is in what? Meter, this is the acceleration, meter per second go, meter what? Per second now. So remember, this kilogram meter per second square is equal to what? 1 Newton. Because conventionally, force is, the SI of force is Newton. So 1 Newton is equivalent to kilogram meter per second square. So now the dimension here, this is the unit. Dimension here should be what? Now here we have mass, kilogram code. We have capital M in dimension code, capital M. Meter, length, capital L. Then seconds, T equals to minus what? 2. This is dimension, this is the SI unit. Remember, in dimension, we said we use capital M for kilogram, capital L for meter, capital T for second. Now, after force, we have another unit. And we have another quantity, we call it what? Work or energy. Work or what? Energy. They have the same SI unit, but the SI unit is in what? Is in joules. Now, we say that force or work is what? Is force times what? Time distance. This is the formula for force. Force times what? Time distance, S. Now, remember the force here, this is the SI of force. That is what? Kilogram meter per second squared times seconds. No, times distance. This is distance, not second, please. So the SI of distance is what? Is meter. Now, yeah, this becomes what? Kilogram meter times meter is meter square. Go. Then we have S minus 2. So remember that work is also measured in joules. This is equivalent to 1 joules. Because by convention, work or energy is measured in joules. Remember that 1 joules is equivalent to 1 kilogram meter square per second. So now the dimension here should be what? Now, kg mass is capital M. Then meter here is what? L square root. Then we have time second is capital what? T, to the power of minus 2. This is the SI unit. This is the one dimension of work. Then the next one is power. When that power we say is work all over time. So the SI of work in this case is this one, is kilogram meter square per second square. All over what? Time, which is in second. This S can still come up here. We have kg meter square minus 2 minus 1, we will have minus 3. Remember, when this comes up, it will become what? Minus 1. So minus 2 minus 1 is what? Is minus 3. What I mean here is that you have kg in this case, meter square per second square times, when this comes up, we have that kg meter square Pascal square here minus 1 we take 1 s kg meter square Pascal cube. This is how we got this. So now remember that this again, just like force work, power is also measured in watts. When 1 watt is equivalent to this. You see? So now the dimension here will be kg, capital M. M, capital L. But here it has to square go. S, capital Q go, times T to go about minus 3. So now, again now for example we have, for example now again, we have another one like pressure. Now, pressure here is force over what? Area. Remember, the SI of force is this. You said kilogram meter Pascals all over area. Remember that area A is length times length. Go. Area A equals to what? Length times length or length times height. Go. Length is in meter and then in meter equals to what? Meter square. Even the SI of area is what? Is meter square. So now, from here, 1m can cancel out 1m here, go. Will be left with kilogram Pascal all over what m. Since 1m cancels out here, this m come up, we will have kg meter per meter. When it come up, it becomes 1 minus 1, go. You follow the same rule per second square. So now this dimension here, kg capital M, M capital L minus 1 capital T minus 2. This is SI for ratio.